Sure. We'll wait for 5 more minutes. No issues.
Thank you, sir.
Thank you.
Sir, shall we start the session now, sir? Kottilingam, sir.
Yes, ma'am. We can start, ma'am. Yeah.
Thank you, sir.
Sure.
Good afternoon to all. It's my immense pleasure to introduce today's resource person, Dr.K. Kottilingam, sir, Professor SRM University, Kattankulathur campus. Dr. Kottilingam, sir, received his ME and PhD from Anna University. His main area of research interest includes next generation data management algorithms, health informatics, and social data analysis. He is one of the principal investigators for Spark IITK project with University of California, Davis campus, USA, for an amount of 59 lakhs. He has served as guest editor and reviewer for IET, Springer, InterScience, Elsevier, and Benham publications. With 12 years of teaching and research experience, he is currently working as an associate professor in School of Computing, SRM University, India. He has published various research articles in high-reputed science citation index journals. In 2020, he has published 2 papers in IEEE Globecom held in Taiwan and a flagship conference with a high index of 54, with H index of 54. He has research collaboration with University of California, Davis, USA, Virginia Tech, USA, Manchester City University, UK, RIT, USA, La Trobe University, Australia, Rakia University, Turkey, and UAM, Malaysia. Now we invite our resource person, Dr.K. Kottilingam sir, to share his research idea on the topic of industrial automation using sensors. Welcome you, sir.
Thank you, ma'am. Thanks for your introduction. That was a fantastic one. Even I didn't thought of things which went for my life for all long in this last 1 years. Thank you so much.
Thank you, sir.
Good afternoon, participants. I welcome everyone who joined now for this AICT training and learning program, specifically toward the sensor technology. Before starting my talk, is that I'm audible?
Yes, sir.
Okay, thank you. So before starting my talk, I would like to convey in terms of what verticals I would like to convey between this 1.5 hours and 2 hours, what I would like to convey actually. So let me share my screen for some time and I'll tell you in what verticals I'm going to share my thoughts on this. Yeah. Give a minute. I'm sharing my screen.
Yes.
So my screen is visible, right? Okay. So don't worry. I have this triangle to talk about regarding this industrial automation using sensors. So as a person from this mobile networks and data networks interested research group, I would like to share some thoughts about this. This innovation happened in the industry of networks. Then I would like to talk about the type of sensors used in generic term with respect to different industry. Then I can move to this physics and theory and what are the norms and what are the laws being used in terms with respect to the sensors and transducers. So these are the 3 verticals I'm going to talk with you for this this next hours. So speaking about this industrial standards, is purely I'm going to speak about this network standards and how it has been improved from the low data rate to the high data rate what we have been conceiving now. And the conversion of this from this first generation to 5th generation. And while speaking about this type of sensors, from the basic sensors to the different type of sensors used in different commercial purposes as well as research purposes. This physics and theories, I like to talk about all the laws is being used with respect to the conditions. Okay, yeah. Open my yes. Okay. Yeah. So I told you I'm an associate professor, as said by one of our friend. I'm an associate professor in SRM School, Institute of Science and Technology, with respect to School of Computing. I once again welcome you all for this talk. This is my talk overview, introduction, data network standards, types of sensors, physics involved and useful links. See, what I have done is I have pasted these links, whatever which are useful for you. After my talk, I'll talk about this thing. The links you need to refer for the next step or the next stop after this talk, what you mean where that you need to refer some sense of knowledge. In the sense you can refer these links. That will be pretty interesting to know about all these links. I'll talk to you about after this talk section. Narratives website. I'll talk about this thing after my talk. Yeah. Yes. So we are today to talk about this industrial automation, when this automation happened, and in 1946 it was being coined in the Ford industry. You know that Ford industry is a motor company which they produce enormous amount of motor vehicles. It was coined in the year of 1946 actually. In terms of definition, they have given us is an integrated, flexible, and low-cost system platform that consists of various equipment and elements which perform a wide variety of functions like sensing, control, supervision, and monitoring related to industrial process. So before that, I mean, 2 to 3 decades, we are in terms of country like India, we don't have, such an enormous amount of automation process actually. This automation process we do care about only in terms of this automobile industry, not with all sort of industry. Today, every industry, every edge cutting industry has been into this automation process. Yeah, very obvious it will reduce the human manpower, but there is no other go that you need to stick on with the system. In the sense you need to be automated. Everything needs to be automated. Not only this, this high-end physical automation industry like robotics are very large. Motors has been invented. Not like such an industry like software industry is also automated with respect to all sort of software production and management. This entire software life cycle is being automated, right? So there is an equal growth in terms of this physical component automation industry as well as the logical component in automation. The growth is enormous when compared with last 3 to 4 decades. We are into a much improved state actually. Fine. So as I told you, this is the word is attributed to D.S. Harder, an engineer manager at the Ford Motor Company. Okay. He has been coined this term automation. This is very much required automation. Yeah. Okay. So I told you that I am going to talk about this, network standards, because every, sensors, what we do or what we use in day to day or with respect to data actually. So we need to know this topic. This is pretty much important. And even though you send some data, suppose let us take it as, vehicular technology, this GPS is captured, and if you navigate from a source to destination, in everything you do it with your cell phone. So you need to know about this. The growth, happened in terms of this this mobile industry. As you know that we are very fond of using this IEEE 802 standards, and purely this slide speaks about IEEE 802.16, that is the mobile WiMAX technology. I would like to tell you that this WiMAX standards has been started in terms of 2002 with 75 Mbps. In 2009, they came with the 2007 to 2009. They came with this mobile WiMAX that is called the IEEE 802.16M standard 1. Between 2007 to 2009, they had this 1.5. After that is with 125 Mbps. So you check here from 75 Mbps to 125 Mbps. Then they had an emergence of 300 Mbps after 2009. And we had enormous amount of evaluation has been happened. That is, I have given in a separate slide. I'll show you. Even though the mobile WiMAX, is upgraded mobile WiMAX to 5G, it has been upgraded up to 20 Gbps. You check here from 75 Mbps from 2007 to 20 Gbps. We can't imagine the speed of this. Data networks. So why I'm speaking is in the sense, what we do with all types of sensing and transmitting data, we need to know this standard. It is pretty much required. And even though we have been into this 20 Gbps, data growth, and we are still facing numerous number of, data side issues actually. Even though we have and fine-tune our cutting-edge sensor technology, we do have the problem of this, managing data in the backends. So you think that there is a physical industry and there is a logical industry and there is a data industry. They all are, the corners of a triangle. The physical industry, the one who produce enormous amount of sensors. The logical industry, those who work and they capture the data and they produce, large volume of data. The data industry, the people, those who manage pure data, purely data, like Oracle or SAP, they people work on purely on data. Company like Huawei or other mobile networks company, they used to process data and they satisfy their customers with respect to standards. So even though we do have this iPhones and this point has been specifically taken from until 2017, they do have a problem with the dead connection, drop calls, and bad coverage. Whatever the data taken, it is being taken from the US industry, not from this, Indian. So we can pretty much know that they have the, cutting edge standard in terms of mobile technology. They do have the sort of this problem being there, even for this iPhone users. So this is the growth from, this, the enormous amount of growth, what we are being, using or what we are being utilizing. This various standards is being used with commercial purposes, research purposes. Fine. So from IEEE 802.11, you can check here this line. IEEE standard for ubiquitous clean community control network protocol. This is enormous. This is huge actually. You can't compensate the power what we use for consuming the data. And when you want to consume an enormous amount of data, you have to utilize enormous amount of power that is proportionally equal. So this clean community control network protocol is being made with respect to reducing the consumption of power, or reducing with respect to working with respect to the ecosystem, green ecosystems. That is one of the fantastic protocols actually. So other than we have enormous amount of layered improvements has been happened with respect to physical layer or medium access layer or what application layer. We have different protocols has been introduced. So these are some of the sort of things that which speaks with respect to the IEEE data standards. So this thing I want to share you actually. This is a specific research. 4 domains is happening in terms of this industrial revolution with respect to this cloud distributed 5G core layer actually. So we have a distributed unit with enormous amount of user equipments. Every user equipment is connected with the base station, and all these base stations are connected with the core layer. We have a serving gateway, or we have mobile management entity, and we have PGW. All this sort of CPF or UPF, user the function are connected with the edge router and internet content server actually. So they call this as evolved packet core. They usually call this as an EPC in terms of this industry standards. And this is a pure what the lower layer where we do or where we connect with our base stations actually. We think about the number of sensors has been there around you, where everyone using their cell phones actually, and it is enormous and huge actually. When there is an enormous amount of consumption of power, when people are tend to share their data with everyone in the network, the consumption of power is equally increases high actually. So we do have the system of sorting out the data to be retrieved in an optimal manner. So we have experienced that when you buffer an YouTube video, once it is being seen, it will be easily buffered back again actually for some time. What I'm speaking for some time actually. So what they'll do is, suppose say for example you take this UE1 actually, and he is requesting some sort of information from the base station. And it is being also requested through this enormous amount of people, those who are connected through BS. Say for example, 1, 2, 3, 4, or say these 4 people are requesting the same data. Let us consider it is a pandemic and everyone requests data about COVID-19. And the information is, unanimous for everyone. So no need to get back this information from the internet server again and again. Before this invention of this artificial intelligence of managing data optimally between this, DRAM, that is 5G distributed RAM, we do retrieve data from this internet content server. Now we have the optimacy, we can retrieve from the nearest server. That has been the concept of implementing this, what E-Node B or, what we call as ENB actually. So these are some of the standards and some of the principal things are happening in terms of 5G networks. We are tend to spend a lot of data rates, and we are tend to spend a lot of money, and with respect to power consumption too. So my part of this data standards was somehow over, and we have seen this. It's such an introductory part about this data standards and how it evolves from this first generation to the core layer. And we all are trying to use, drive cars. And when we think about the cars, what we have with our father or forefathers, and they do have cars, they don't have sensors actually. They have, they have a system which is entirely different from what we are using today actually. You can see the number of sensors available. These are the, sensors of a Volkswagen car actually. Then oxygen sensor, and mass airflow sensor, coolant temperature sensor, tire pressure monitoring sensor, camshaft position sensor, crankshaft position sensor, fuel injection pressure sensor, NOx sensor, accelerator pedal sensor, and map sensor, and transmission speed sensor, position sensor. Say they do work in a centralized system. If one system or one of the sensors fails to communicate, it will be easily displayed with the user's car dashboard. So we are in this era. We are whether we know or we don't know. So how we people used to have drive cars actually. We are very much fond of using this. GMap, that is Google Maps, which comes with this today's top or higher end cars actually. They have this navigation system, and some community they are tend to know about this all sort of engines, fuel, and everything will be displayed. Sorry, everything will be displayed once you switch on the car. And these are some of the facts that we want to know, that we should know how this this basic sensor works in terms of automobile industry. Okay, so this is the location where it is being located. Every sensor has been located in a certain position. From the dashboard to the engine system, we can see the differences actually. We are, let me take one single one, that is an air conditioned relay actually. When we buy cars, we do have this, weather sensors. With respect to the outer weather, your air conditioning system in the car will change dynamically. That is one fantastic invention in this air conditioning system of cars actually. Even do with our in homes we have this cutoff of the temperature values will be there. When you have the different room temperature, the AC changes its temperature actually. When you have a higher temperature, the AC cools down. When you have a lower temperature, the AC changes according to the lower temperature. So these are some of the technologies which we which amazes us with respect to the sensor industry actually. Fine. Not only this, air conditioning relay, there are pure braking system, this ABS. That is one system. It works with this, sensors too actually. So the before ABS, we don't have this the system before 2 decades. Especially they started inventing after this 2000 to 2005. This ABS came into market, and they are gaining much interest towards all sort of even. The planning commission of this automobile industry, they are recommending this ABS, and airbags are pretty much compulsory for all the automobile sectors, those who being used for commercial purposes actually. Fine. Yeah. So sensors are now becoming a commodity, and soon can easily be designed into most any device. Yes. So without sensors, I don't think, we can't construct anything in the near future actually. It has been into every single part of our life, every single part of our life. If it is being with our life, and obvious it is being with every industry actually, what we work or what we consume from the industry or what we receive, everything is being into sensors actually. Yes, these are some of the facts about the age of the sensor. When we talk about sensors, we should talk about this interactivity. So you should, when you sensors are purely a medium which interacts with the outer exposures and observes the outer exposure and converts and energy and supplies into a different output actually. That we can see in the upcoming slides. We have examples for that actually. Small low-cost sensors easily available to measure nearly everything, like thermometers. We even now we do have this. Oxiometers in our phones. They can buy up to 1,200, 1,500. We don't say oxiometers for every single time when they have a different sort of breathe. Even without COVID-19, we do running with the this oxiometers in our phones. Moore's law makes processor capable of meaningful exporting the data in real time. That is one of the biggest invention. How this data consumption, really affects this performance of the systems. That is one fantastic thing that we want to, that everyone should know. These are some of the barriers to entry, easy to try things. Deaf and blind computers. We don't really know what will really come after keyboard and mouse. Yes, really, we don't know actually. We do have this miniature keyboards and mouses in our cell phones that has been emerged already, and we don't think we can. That there is some more miniature will come in future. Actually, it might come at any time, but we are not sure about that actually. So you can't realize your vision for the future of interactivity by buying a card and plugging it in actually. So if you think that some technology is the higher end, it is not really actually. When you think that wow, this is the technology that we have been waiting for, it is not really. It is the starting point of the tech. Invention. Fine. So sensors like how produce iPhones has been produced enormous amounts. iPhones are copied with Samsung. Whenever they produce a new iPhone, the same type of features and everything will be stored with the new Samsung cell phones. That has been there for so long time actually. Sensors are permeating everything, interactivity everywhere. Yes, from toys to automobiles to smart homes. Smart homes. I don't think we are into smart homes now actually. We will be in smart homes after 10 years. It will take another 10 years definitely. Because country like India, it is being with crowded with enormous amount of huge population. It is not an easier case to implement smart homes. We have smart offices, we have RFID in offices. We do have to punch every single day. I don't think that will be an invention with your homes when you are entering your home or exiting. That is no way possible. That we don't have such a culture in our homes. I don't think that will interrupt really actually. Smart homes, we do have, oven, we do have OTG, and we do have we do have air conditioners, and we do have every sort of home appliance we do have, but we are not making into an entire IoT system, smart homes. Fine, that will, I don't think that will interrupt in some time later. Actually. Yes, from burglar alarms to ubiquitous computing. Yes, the smart homes comes in this ubiquitous computing. So sensor networks as extension of the nervous system. You check here for every sensible part of us can have a different sensor and we can convert into an energy and we can interrupt and we can have some study on it actually. Fine. They have implemented this is being taken from this MIT course where they do have this automation course. I've taken this specific image from there. That's what I have cited over here, specifically taken from MIT course where actually how it is being connected from ears, nose, eyes. What you see or what you interpret, what you smell or what you observe, everything can be converted. Everything can be converted into different sort of knowledge actually. Fine. Yes, people those who are working in terms of NLP, natural language processing, people those who are working for them, different dumb. So in terms of converting their gestures into knowledge, that research is keep on going on. So I don't think there is much difference or between this nervous system conversion of an entire sensor network into a nervous system is It's always been possible actually with some sort of limitations. So we can classify the sensors into two actually, active and passive sensing, contact and non-contact actually. Active sensors do require some sort of excitation or power to stimulate actually. And passive sensors are not like that actually. They differ from these active sensors. And here there is been given, an image has been given in terms of 1, 2, 3, 4, 5. It says that which are contact and which are non-contact and which require power and which require stimulate environment. So that has been done over here. And we are pretty much known about this analog to digital conversion. I mean, when you sense the environment, it is purely analog actually. When you sense the temperature or when you sense the air, when you sense some sort of noise, it is purely analog. And you need to interrupt into some data, you need to have A to D converter. That is one thing pretty much required to interrupt, to make some interruption for your data sense through a sensor actually. Yeah. So these are some of the pretty much, sound areas where sensors is being applied and how it really works actually. It has been going over here actually. Pressure, volume of fluid in a tank, velocity, temperature, angle from vertical. So this displacement can infer actually. When you talk about sensors, when there are different categories: commercial purposes, research purposes, industry purposes. They do have different purposes. When everyone, in our home, we are fond of using this simple DC motor, buying from an electronic shop to make some toys for kids. That is different from a very large DC motors. It's been used with an electrical power industry actually. So we do have miniatures things, types in every sort of industry actually. So in the past 2 to 3 decades, we used to sense all sort of environment sensors. It has been pretty much gained more popularity with weather or temperature or velocity. They gained a lot of attention towards this 2 to 3 decades back actually. So I'd like to give a walkthrough on this sensors and transducers. As I told you already, I have this classification of top the industrial standards and types of sensors. We are into this type of sensors actually. One second. Yeah, sorry for interrupting.
Sir.
So, yes, ma'am.
No problem, sir. No, sir, no, nothing.
Okay. So, and walk through with sensors and transducers. So, we have seen that about the standards in mobile industry, the data network industry actually. Then we have seen about this basic sensor networks or nervous system can be interpreted with respect to a sensor network. The age of sensor, we have seen that. Now we are moving to the core part and walk through with sensors and transducers. So in a definition, they have given that electronic system or circuit must be able or capable to do something, and sensor and transducers are the perfect components for doing this actually. So this conversion from from an outer exposure observation to an interruptible data to an decision making knowledge, everything can be done through the sensors and transducers. A simple example can be when there is an rain in the outside your in your car, automatic wiper works actually. When there is a minimal rain, the speed of the wiper differs. When there is higher rain, the speed of the wiper goes high. So it depends, it works. When it captures the knowledge that there is a heavy rain and we need to wipe it like anything. When the rain comes down, when there is a minimal amount of rain, the wiper works very slowly. When there is no rain, the wiper never works. So observation and interruption, then decision making. So this all can be done through the sensors and transducers. The word transducer is the collective term used for both sensor, which can be used to sense a wide range of different energy from such as movement, electrical signals, radiant energy, thermal or magnetic energy, etc. Actuators, which can be used to switch voltages or currents, we'll see that what it is actually. Yeah. So choosing the right sensor, there are different types of sensors in market, sensors and transducers in market, where which sensors are applicable for which type of application. And we need to be very choosy on that actually. It is not really choosing the right sensor. I mean, knowing about the right sensor and making a right application and connecting with that, that is much required when you want to make an entire ecosystem for an observation to one decision making actually. The type of input or output transducer being used really depends upon the type of signal or process being sensed or controlled actually. Devices which perform an input function are commonly called sensors because they sense. This word is pretty much important because they sense a physical change in some characteristics that changes in response to some excitation. As I told you, this, I mean, automatic wiper working in a car actually, with respect to rain and with respect to the speed of the wiper. When the rain is high, the wiper works high. When the rain is low, the wiper works slowly. So that's it actually. For example, heat or force and convert that into an electrical signal. Devices which perform an output functions are generally called actuators and are used to control some external devices. For example, movement or sound. Yes. This is also been correlated with our, I mean, rain wiper sensor in actuator terms. So electrical transducers are used to convert energy of one kind into energy of another kind. Yes. Say, for example, when you speak in a mic and you have an amplifier and then you have a speaker. This is the mic, and this is the amplifier, and this is the speaker. Check here what we receive. We receive, say, for example, we receive the signal alpha and we process through, I mean, we are sending an input to the mic, and amplifies it, then send the same amount, send the same alpha. And what we do is, what we work is, we are not making any sort of, I mean, disturbance with the energy what we consumed actually. A microphone converts sound waves into electrical signals for the amplifier to amplify. It's a process. So the microphone is an input device, and amplifier to amplify is a process. So you can see that electrical transducers, specifically, what they do is they do have an input device, they do have a process, and they do have an output device to transmit action. A loudspeaker converts these electrical signals back into sound waves. And an example of this type of simple system is given. That is what it is. I will give here. Okay. So there is no, there is no, if suppose we say, for example, we have received the sum of alpha amount of energy, that same alpha will be delivered over here. With respect to amplification, we are we are broadcasting in a speaker. So one sort of thing is an input device and one sort of thing is an output device. As I told you already, electrical transducers are used to convert energy of one kind into energy of the. So these are the market available common sensors and transducers. The quantity being measured and the input device and output device. Light level, light dependent resistor. There are different input devices: photodiode, phototransistor, solar cell, lights and lamps, LEDs and displays, fiber optics. Temperature, we have thermocouple, thermistor and thermostat, resistive temperature detectors, heater, fan. Yes, you can check this correlate with the input device. You can correlate this input device with the output device. That is, input device is specifically called as sensors and output device is specifically called as actuators. Sense and actuate. Sense and actuate, actually. You have to sense and actuate. When someone pinches you, what you'll do actually, say for example, if pinching is an observation and you are tend to, I mean, what will make a noise actually. Right. When someone slaps you, automatically you'll make a noise. You'll do something. You'll be you are in the mode of, I mean, you'll be so aggressive or you'll be so angry. You want to give it back to the person who slaps you actually. Fine. So the same way sensors and actuators work. When someone pinches you, the signal converts. The signal is being observed and it is being transmitted to your brain, and it comes out as a noise from your mouth. Actually. The same way. So things which are being given over is a light level, a temperature level, pressure level, position level, speed level, sound level. So whatever industry we are being into there, you can't. What deviate from this? All sort of quantity is being measured. These are the common quantities. These are the very generic common quantities what we measure and being given as an input to the sensor, and will come in a different or come in. In a user interactive form through an actuator. While speaking about pressure, we have strain gauge, pressure switch, load cells. When we speak about for this strain gauge, we have lifts and jacks, electromagnet vibration, position potentiometer, encoders, reflective slotted opto switch, LVDT. We have actuators for motor, solenoid, and panel meters. Speed, while we speaking about speed, quantity being measured as a speed, tacho generator, reflective slotted optocoupler. You check here, this they used to have this same actually. It's a switch and a coupler, reflective slotted and slotted opto switch and opto coupler. Doppler effect sensors, they are pretty much known for this. Making images in ultrasound or in X-ray. And Doppler images are the major, backbone behind, major knowledge behind using this, conversion of, images. AC and DC motor, stepper motor, brake, sound, carbon microphone, isoelectric crystal, bell, buzzer, loudspeaker. These are the common correlation between the quantity being measured and an input device and an output device. These are market availabilities. We can see in every part of this. Wherever we roam, we used to see all sort of things actually. So let me move to the point number 1, where we started this types of or classification of sensors actually. All types of sensors can be classed as 2 kinds, either passive sensors or active sensors actually. I told you active sensors need some sort of external power supply to operate, that is called an excitation signal. Okay, which is not required in terms of passive sensors. And passive sensors, they do have some sort of mechanism to sense an outer exposure. I'll tell you what is an example for that actually. Active sensors are self-generating devices because their own properties change in response to an external effect producing. For an example, an output voltage of 1 to 10 volt DC or an output current such as 4 to 2 milliampere hour DC. Active sensors can also produce signal amplification. Unlike active sensor, passive sensor, they don't require any sort of excitation voltage actually. Instead, they generate an output signal in response to some external stimulus. External stimulus is like the temperature, weather, they do change and they response. This passive sensor's response with respect to the outer exposure. For example, a thermocouple which generates its own voltage output when exposed to heat actually. Yes. That is one classical example. We can see this thermometers to observe. Then passive sensors are direct sensors which change their physical properties such as resistance, capacitance, or inductance with respect to the observation. So we have seen about this active sensors, passive sensors. We have seen about the sensors in a car, and we have seen about, sensors and actuators, and what input can be used to communicate through an input device and what we receive as an output, that we have seen. Now we are moving to the core part again, that is analog and digital sensors. Analog sensors produce a continuous output signal or voltage, which is generally proportional to the quantity we measure. Yes. And digital sensors are they are different from this analog sensors. I'll tell you how actually. And with respect to the physical quantities such as temperature, speed, pressure, displacement, strain, are all analog quantities as they tend to be continuous in nature. Yes, you need to sense an analog signal will continuously. Then only some sort of prediction is possible actually. That is when you miss a higher pressure or when you miss a higher temperature, when it cools down or when it comes down, and when you are not observing at the upper threshold value, there is no way possible you can't predict when it will come back again with respect to the. For example, the temperature of a liquid can be measured using a thermometer or thermocouple, which continuously responds to temperature changes as the liquid is heated up or cooled down. Yes. Yeah. When you have a higher temperature, when you have when temperature goes high, or when the temperature comes down, I mean it's low, it needs to be keep on measured. That is the major point behind using this analog sensors. Basically, this we have already in nature. I mean, in before 2003, we have this. We are fond of using this analog sensors actually. Right. Before this invention of digital sensors, we have this analog sensors for measuring pressure, speed, temperature. We do have this analog sensor. We are fond of using this all sort of things. This displacement, strain, they are all being used in the industry, not with the regular, commercial purposes. Yes, this thermocouple and analog sensor, which measures the temperature heat. When you heat up, there is a different analog output symbol. When you melt down, when you heat down, when you cool down, you can get a different output signal. The graph is being given actually. With respect to time and output signal, how the signal changes actually. Fine. When you heat it up or when you cool down, the output what we receive will change that. So we had been talking about this A to D converter from any in terms of this active or passive sensing. We had been keep on talking about this A to D conversion. We all are fond of knowing about this. Computer words. 8-bit, 16-bit, or 32-bit, 64-bit. Sorry, 8, 16, 32, and 64. It is what we are using the 16-bit, 32-bit, and we are now using the 64-bit computers. So when you know something, this industry, when you have a higher boom with the processing industry, that type of mechanism, that type of invention needs to be there to increase the physical industry too actually. Fine. When you have a higher software and you can only run in a 64-bit machine, what will happen? And you do have systems which will only work with 32-bit computer, there is no purpose at all. Fine. Yes, as we all know about this IPv4, no. IPv4 and IPv6. Why this IPv6 is not familiar in the sense this entire country, this entire universe has been constructed with V4, that is 32-bit addressing. When you have a new invention of IPv6, how they will change their backbones? It is tough to change. It is not an easier case to change this entire backbone. Fine. From V4 to V6, we need a specific conversion. From V6 to V4, we need a specific conversion. So people thought of making this conversion is easier than changing this entire backbone systems. Fine. Also, analog signals can be easily converted into digital system signals for use in microcontroller systems by the use of analog to digital converters or ADC. Digital sensors produce a discrete digital output signals or voltages that are a digital representation of the quantity being measured. Yes. When you want to measure a large amount of rainfall, and the simple data can be represented TVC actually from morning 8 a.m. to evening 6 p.m. We want to measure the rain through a sensor, rain observe weather sensor or a geographical sensor. We can observe and we can make it in a single paper. So that is what the benefit of using this, digital sensors when compared with analog, and the signal can also be easily quantified. We can also convert, and we can also transform. We have Fourier transform, we have Laplace transform, we have wave transform, we have n number of filters are available. You can use that filters and you can easily capture and you can filter it out and you can transform it and you can make it as a knowledge easily. The digital sensors produce a binary output. As I told you, they are being ones or zeros actually. As we how we represent words in computers, right? How we represent 7 actually 111, right? Then I'm right, 111. So in the sense, it can be represented any data which can be easily converted into a digital format. This means then that a digital signal only produces discrete values which may be outputted as a single bit or by combining the bits to produce a single byte output. That is serial transmission to parallel transmission. Yes, using a light sensor and displaying it through digital signal actually. So with respect to the observation of available light outside, you can display or you can switch off or switch on the light actually. When there is a higher light, no need to switch on the lights. When you have a natural light, when you have a poor light inside your room, you can switch it on the lights whichever there. What it is being represented here is we can display it, we can observe and display it. That is, we do have different sort of light sensors. We'll see in the lower slides. I have a slide about this light sensors. How this digital light sensor works and convert this digital output signal with respect to the available light. Position sensors. These are much required in terms of this mechanical industry or a robotic industry. What we do with robotic arms, the movement of robots or the movement of shafts or the rotation of shafts or the rotation of disc. These position sensors are much required. When you apply a brake, when you are running a car with respect to 130 km per hour, when you apply a brake, when this ABS works, this anti-braking system works, how it needs to be positioned, where it needs to lock, and how strong it needs to lock the disc so that the car can stop at one single moment. So every time there is no difference between the amount of pressure applied on a brake shoe actually. You don't apply different pressure on a brake shoe. You can only apply with respect to your aggressiveness. But there is that your aggressiveness never being converted into energy to a brake shoe actually. That won't do actually. That is a different mindset. I would like to tell a story about this torsion pendulum, about this aggressiveness and human artificial intelligence. I will take a break here and I go back and take my yes, one moment. So I've studied from my favorite professor. I'll tell you who it is. I've also been doing the slides actually. Who the professor it is. I've studied this lecture and it was so interesting to know about this the known fact of pressures and artificial intelligence. And we are very much known about the torsion pendulums. Fine. There is a ball inside, and if you swing this ball, say for example, point A, my screen is visible, right? Yeah, I'm sharing. Okay, no problems. Suppose this is a point A and this is a point. If you swing it from here, for example, it is 3 meters. You swing it from here, you are taking back and swinging here, it will go to 3 meter again. It will go to 3 meter. From left to right, it will swing left to right, it will swing 3 to 3 in one single stroke. Then it will come to 2 after a certain time. Then it will come to 1. Then it will come to 1 in the right side as well as the left side. Then it will come to 0.7 or 0.7 and 0.5 and 0.5 and 0.3 and 0.3 and 0. This is how it swings. From left to right, from 3 meters to coming back to the origin, it swings. Fine. When you leave the torsion pendulum and you are making only one single swing and leaving it. Only one single swing and leaving it. Fine. So let us consider that. I'll tell you one. I'm asking you to assume that we are holding a ball like this. We are holding, yes. Suppose we have this. What torsion pendulum ball with an kg of 10 kg of torsion pendulum ball. You are holding with your arms like this. You are holding with your arms like this. Okay. So what we are doing is, okay. So what we need to do is, and we need to walk back. We need to walk back to 3 meters by swinging like this, and you need to release it. And you need to release it. Okay, fine. And you need to release it. As per physics, what it says about torsion pendulum is, you have to leave the ball the 3rd meter. You have to leave here in point A. I think you are yours. You have to leave in point A. You have to leave it. You go back to this 3 meters of point B. But what this human instinct, what this human, A says, and we do have sort of things, we'll push like this. Every time, when you don't leave the ball here, you don't leave the hands here. What do? You push actually. So this extra pressure applied on this object will go up to, say for example, will go up to 5 meters, and you are already standing in the 3rd meter. It will hit you back like anything. It will hit you back like anything. Yes. It was one of the fantastic theories about a professor in MIT, and I'll share his thoughts. I have these videos too. Definitely. Why I have been talking about this in the sense, what is the difference between human intelligence and machine intelligence? How this human intelligence entirely differs from machine intelligence. Human intelligence cannot be same at all the point. Suppose you have 10 iterations. You want to make it for 10 strokes. It can't be the same for all these 10 strokes. But machine intelligence, it will be same for all these 10 iterations. That is the difference. Yeah. Thank you. Thanks for allowing me to talk about this in our topic. It was so interesting. Yeah. Yes. This topic, emerged us to talk about this position sensors. That was so interesting. As their name implies, position sensors detect the position of something, which means that they are referenced either to or from some fixed point or position. These type of sensors provide a positional feedback, where it is, how it is being located, what is the radius, and how far this object is being residing, and the curvature. Everything can be observed through a position sensor. One method of determining a position is to use either distance, which could be the distance between 2 points, such as the distance traveled or moved away from some fixed point, or by rotation or through an angular movement. The very known example, torsion pendulum you can take. You can operate a torsion pendulum through a sensor. It will be different. Even without no sensors, you can operate a torsion pendulum. Say for example, you need to operate torsion pendulum through a sensor. You can measure the exact swing between A and B. From the left side to right side, you can measure the exact swing. Whatever we are speaking is a pure assumption. We can simply measure it. What fraction it has been missing from the left to right or the right to left, we can measure it actually. The rotation of a robot's wheel to determine its distance traveled along the ground. Yes, that is one classical example has been given. Either way, position sensors can detect the movement of an object in a straight line using linear sensors, or by its angular movement using rotational sensors. So I repeat this line back again. Either way, position sensor can detect the movement of an object in a straight line using linear sensors, or by its angular movement using rotational sensors. Yeah. So this can be utilized to see the linear and an angular movement. For a linear movement, we do have linear sensors. For an angular movement, we do have rotational sensors. Some type of, surveillance camera comes with this 360-degree rotational, and some do comes with this 180-degree rotational. Some do only cover up this straight 90-degree. So there is a difference, right? So this coverage difference with respect to the amount of rotation happens inside the camera. The most commonly used of all the position sensors is the potentiometer, because it is an inexpensive and easy to use position sensors. So proximity, proximity is, the amount of distance is being, assessed between one point to other point. They call it as a proximity. There are inductive proximity sensors are available. Another type of inductive position sensor, as we have seen that linear sensor and rotation sensor, an inductive proximity sensor is also a part of this position sensor, also called as eddy current sensor. While they do not actually measure the displacement or angular rotation, they are mainly used to detect the presence of an object in front of them or within a close proximity. So these proximity sensors are used to measure the objects which are which in front of him or between any two endpoints from A to B. Hence, their name proximity sensors. One main disadvantage of this type of position sensors is that they are omnidirectional. That is, they will sense a metallic object either above, below, or to the side of it. So there is no more, dimension is possible. They are purely omnidirectional. They will sense a metallic object with respect to above. From height. From top to bottom, or either side actually, or to the side of it. Also, they do not detect non-metallic objects. That is one thing we need to be very clear about that. They do not detect non-metallic objects. Although capacitive proximity sensors and ultrasonic proximity sensor are available, other commonly available magnetic position sensors include reed switches, Hall effect sensor, and these are different type of sensors. If we talk about this thing, it will go like for another 3 to 4 hours. And for every topic, there are different amount of physics is available. There are different amount of, for using this type of position sensor, you should use a different filter to, what quantify the energy. When you are using an inductive proximity sensor, the quantification is different. So it moves like anything. What I have captured here is a generic point of thing for every, sensor that is being used in the industrial automation process. Rotary encoders are another type of position sensors which resemble potentiometers mentioned already. These types are actually non-contact optical devices. They don't contact, used for converting the angular position of a rotating shaft into an analog or digital data code. How it rotates, the interpretation of rotation. Say for example, when your arm reads, when your disk arm reads your data in your hard disk, how it rotates actually, how it moves from one point to other point, what curvature it moved, and what is the radius between them. And that can be measured actually. In other words, they convert mechanical movement into an electrical signal. That is one classical definition has been given. It has been given that they convert mechanical movement into an electrical signal, preferably digital. Temperature sensors used to measure the not only this weather. They used to measure all types of temperature generated through this. Even in car engine, when you are running a car for 300 to 400 kilometers, you do have a different sort of heat will be generated between the engine. So it will generate, it will indicate in your car there is a problem in the engine. So what you will do is automatically you switch off the car and you come down from the car and you will see what happens inside, and you will wait for 5 to 10 minutes. It will cool down and you can start back again. Fine. These are some very minute or fraction thing which is being there with the running a car engine. Likewise, for every equipment will tend to have a higher temperature. Measures the amount of heat energy or even coldness that is generated by an object or system. They never said that it is only purely used for weather or in a health purpose. It is being used for enormous amount of purpose. There is no, only the amount of quantification is different when you are making a sensor. When you want to sense human body temperature, and you want to sense car engine temperature, it is different, and that needs to be changed. That amount of capturing the amount of observation is being changed. That is what it is being represented here. And you can also, as I told you already, we can use a A to D converter and make it as a digital output. There are many different types of temperature sensors are available, and all have different characteristics depending upon their actual. So a temperature sensor consists of two basic physical types: contact temperature and non-contact temperature types. I mean, these type of temperature sensors are required to be in physical contact with the object being sensed and use conduction to monitor changes in the temperature. They can be used to detect solids, liquids, or gases over a wide range of temperature. So let us consider about this. I mean, high processing. I mean, meat industry. When you have an I mean, the meats are being processed in a high refrigeration industry, the temperature needs to be monitored. Fine. Like an ice cream industry, how they need to process and what temperature they need to hold, they need to keep on monitor the temperature. That needs to be there. That it needs to sense the sense in terms of physical. Very physically it has to sense actually, like how you sense a temperature actually. Non-contact temperature sensor types. These types of temperature sensors use convection and radiation to monitor changes in the temperature. They can be used to detect liquids and gases that emit radiant energy as heat. And they do, when they, I mean, that the difference between contact and non-contact is you can straight away involve physically. That is one thing that you need to know about this contact temperature. Whereas in non-contact temperature, the environment or the specific solid or liquid or gases that will generate some type of radiant. Through that radiant, you can sense it, sense the temperature, and you can try to find that this has been highly radiated. How we sense this radiation with our cell phone towers actually. We do say that it is highly radiated. Don't keep your cell phones near your pillows and where you are sleeping at the nights. Fine. If the radiation is different, you know how this radiation works, no, right? So, say for example, this is a base station. What we call as everything is heat actually. Everything is temperature. Even though radiation is also some sort of heat and some sort of temperature. So this is how it works. Fine. So wait a minute. So you have higher concentration among this, and you have the concentration will be very low when you come outside the circle. So every single stroke or every single picoseconds, it used to generate signals through this, base station for all sort of cell phones, what we use, what we consume data actually. So again, this also generates, that's what we are fond of, we are prone to radiation while using cell phones. When we have houses near, the base stations, operator services, we are very tend to, radiation. While using one single cell phone, and we compare the difference of radiation while using a single cell phone, and we are residing near a tower which supplies enormous amount of signal strength to all sort of communication devices under its umbrella. Yeah. They can be used to detect liquids and gases that emit radiant energy as heat rises and cold settles to the bottom in convection currents, or detect the radiant energy being transmitted from an object in the form of infrared radiation. Infrared radiation. The light sensor generates an output signal indicating the intensity of the light by measuring the radiant energy that exists in a very narrow range of frequencies, basically called light, and which ranges in frequency from infrared to visible up to ultraviolet light spectrum. While speaking about this, this acoustics, underwater acoustics, light sensor plays a, very big role actually. When they want to transmit data in underwater and sea, the spectrum which you use in an air, an empty vacuum air is different from the spectrum what you use inside and underwater. The strength must be very high actually. For that, we use infrared or high ultraviolet light spectrums to transmit signals in the this underwater seas. The light sensor is a passive devices that convert this light energy, whether visible or in the infrared parts of the spectrum, into an electrical signal output. Yes. Light sensors are more commonly used as photoelectric devices or photosensors because they convert light energy into electricity. That is photons to electrons. That is photosensors, photoelectric devices. Photoelectric devices can be grouped into two main categories. There is photovoltaics or photoemissives, etc. And those which can either electric properties in some way, such as photoresistors or photoconductors. So these are the things about photoelectric devices. They can be grouped into photovoltaics or photoemissiveness. This leads to the following classification of devices: photoemissive cells, photoconductive cells, photovoltaic cells. Actually, so for everything there is a different amount of energy is being consumed. The amount of energy the photons have depends on the frequency of the light, and the higher the frequency, the more energy the photons have converting the light energy into electrical energy. That is photoemissive cells. Whereas more light increase the current for a given applied voltage, the most common photoconducting material is cadmium sulfide used in LDR photo cells. That is within the photoconducting cells. Photovoltaic cells. These photo devices generate an EMF in proportion to the radiant light energy received and is similar in effect to photoconductivity. Light energy falls onto two semiconductor materials sandwiched together, creating a voltage of approximately 0.5 volts. The most common photovoltaic material is selenium used in solar cells. Yes, this photovoltaic cells has been very familiar with this solar cells, which has been given as a remedy in terms of green computing. Electrical relays. So we have seen all sort of this sensors and the different sensors used in different conditions, temperature, light, and different inductive sensors, transducers. We have seen that. In the electrical relay, thus far we have seen a selection of input devices that can be used to detect or sense variety of physical variables and signals, and are therefore called sensor. Yes. We have to choose the sensor with respect to the condition, with respect to the environment. They do have a capability to sense a light or temperature or weather. It needs to be chosen with respect to the condition. And for converting them into an output device, for quantifying and converting them into an output device or to making decision making, we need actuators. That is not given over here, but there are also a variety of electrical and electron devices which are classed as output devices used to control or operate some external physical process. These output devices are commonly called actuators. As you know that actuators convert an electrical signal into a corresponding physical quantity such as movement, force, and sound. And what these actuators do is they do convert and give it in a format actually. When you sense it, you sense the raw data, you sense the raw energy, whether temperature or whether rain, you sense the raw energy actually. Actuators, they quantify it actually, they really quantify it. With respect to the applied instruction, they will quantify it and give it to us. Yeah. When you receive and when you are speaking in the microphone, you can apply some sort of features to reduce the noise. Some sort of features to reduce the noise. Yeah. An actuator is also called as a transducer because it changes one type of physical quantity into another. It is usually activated or operated by a low voltage command signal. Actuators can be classified as either binary or continuous devices based upon the number of stable states their output has. For example, a relay is a binary actuator as it has two stable states, either energized and latched or de-energized and unlatched. So these relays is being classified into two. They are energized or de-energized, or we can call it as latched or unlatched. While a motor is a continuous actuator because it can rotate through a full 360-degree motion. The most common types of actuators or output devices are electrical relays. electrical relays, lights, motors, and loudspeakers. One moment, and connect my. Linear solenoid, these are supporting factors like for this types of sensors and actuators. And these needs to be there. I told you there are different verticals for every sensor. When you want to construct an entire industry into an automation industry, you need to know about all this sort of things actually. When you are running a very big refrigeration industry, or when you are running a very big power industry, or when you are running an a factory where numerous number of people are working with respect to textile or yarn, whatever it is, when you want to automate it, you should know about this simple facts. These are the building bricks of construction of a very large automation industry. What we are seeing, they are the building blocks. Every block we should know, then only we can know about this entire automation industry. Yes, this linear solenoid works on the same basic principle as the electromechanical relay seen in the previous tutorial. And just like relays, they can also be switched and controlled using bipolar transistors or MOSFETs. We are very familiar about this MOSFETs. DC motors, they comes in favor with respect to the amount of energy what we want to generate, the amount of power what we want to generate. As I told you already, in houses, we used to buy some small DC motors and HW batteries for making toys. That amount of capacity and energy is very minimal. When you compare to make a very large DC motor to generate a power plant, it is different. So electrical DC motors are continuous actuators that convert electric energy into mechanical energy. The DC motor achieves this by producing a continuous angular rotation that can be used to rotate pumps, fans, compressor, wheels, etc. As well as conventional rotary DC motors, linear motors are also available, which are capable of producing a continuous linear movement. There are basically three types of conventional electrical motors, or AC type motors, DC type motors, and stepper motors. These are very familiar topics in OS semesters when we are doing our engineering. These topics are pretty much interesting. Audio sound transducers, they comes with respect to different heads. When you want to observe a minute audio to when you want to observe a very large quantity of audio, you need to have such a transducers. Include both input sensors and then convert sound into an electrical signal such as microphone and output actuators, and that convert the electrical signal back into sound such as loudspeakers. That we have already seen how this microphone works and amplifies and converts into an broadcast sounds in the speaker. We tend to think of sound as only existing in the range of frequencies detectable by the human ear, from 20 Hz up to 20K kilohertz. It's a typical loudspeaker frequency response is being given, that is 20 kilohertz. But sound can also extend way beyond these ranges. Yes, very large. Megahertz, hertz can also be there. Sound transducers can also both detect and transmit sound waves and vibrations from very low frequencies called infrasound up to very high frequencies called ultrasound. When it is a very low frequency, we can call it as an infrasound. When it is a very high frequency, we can call it as an ultrasound. Yes. So we'll see the summary of transducers, whatever we have seen. We'll see in terms of the summary of transducers. We have a slide. We have 2 to 3 slides which speaks about what we have seen in the previous slides. Yes, as I told you already, transducers are devices which convert one type of energy into another, such as electrical energy into light or sound, or creates an electrical output corresponding to some physical current. Yeah, this is nothing else. What we have seen in the previous example, what a sensor is an input device. The most common forms of sensors being used in position, temperature, light, pressure, and velocity. The simplest of all input devices is the switch or push button. Some sensors are called self-generating. Some sensors are called, I mean, stimulus. Sensor generate output voltages or current relative to the quantity being measured, such as thermocouples and photovoltaic solar cells, and their output bandwidth equals that of the quantity being measured. Output devices we call it as an actuators. Relay provide good separation of low voltage electronic signals and high power load circuits. Relays provide separation of DC and AC circuits, switching an alternating current path via DC control signal or vice versa. Solid state relays have fast response, long life, no moving parts with no contact arcing or bounce, but require heat sinking and solenoids. We have seen that. Permanent magnetic DC motors are cheaper and smaller than equivalent. So transistor switches can be used as on-off unipolar controllers. Bidirectional motor control can be achieved by connecting the motor inside a transistor H bridge. Stepper motors can be controlled directly using transistor switching techniques. The speed and position of a stepper motor can be accurately controlled using pulses. So it can operate in an open loop mode. Microphones are input sound transducers that can detect acoustic waves either in the infrasound, audible sound, or ultrasound. Ultrasound is a higher quantity of sound. We know that. Infrasound is, lower consumption of sound. Loudspeakers, buses, horns, and sounders are output devices and are used to produce an output sound, note, or alarm. Okay. So we have come back to this physical, properties, physics properties which are being used in terms of this electronics industry. Ohm's law, that is V is equal to IR, and V is voltage, and R is resistance, and I is current. It is being quantified like this actually. Combining resistors, how you can combine these resistors? These are common facts. They can be weighted in parallel and which can be converted like this actually. Power and voltage dividers. We are speaking the nuts and bolts of this entire industrial automation industry. I would like to remind back again. We are speaking of the nuts and bolts actually. The power dissipated in a circuit can be given P is equal to IV is equal to I square R is equal to V square by R. Amps, volts is equal to watts equal to 1 joule per second. Signal conditioning, and even though we do talk about the sensors, everything has been converted into, or everything has been observed into signals, and everything, the energy has been observed and converted into signals. Sensors produce different kinds of signals: voltage output or current output. Basically, basically, when we are speaking about, this electrical industry, they produce voltage output or current output. Can't necessarily take sensor output and put right into microprocessor, this A to D converter or logic input. Signal may need high to low impedance buffer, current to voltage conversion, gain, reduction, filtering, discrimination. This can be applied for any signal. How you can, quantifying to an respectful data, this needs to be done actually. So these the things about transistors, bipolar transistors, how it works. We need to have this MOSFET and JFET. How this data, how this signal is being, quantified using transistors. Simple source and emitter followers, source follower and emitter follower. These are some of the ground facts. How some of the circuit structures for JFET and MOSFET, how it is being given using data actually. The grounded emitter switch. This will go like this are all about circuits and FETs. Op-amp model, the ideal op-amp model, how it needs to be there when you want to design an op-amp model for receiving a signal. This is the basic way you can use this model to make it. How this inversion input and non-inversion input can be quantified and make it as an output. The signals, motions were given over here. No current flows into the input pins. Ideal behavior dictated by the external components and signal sources. Comparator with hysteresis. With negative feedback, current flows through feedback register to make V plus or in positive or equal to negative. Okay, so these are the things we can see, and I'll share you actually. My talks comes to an end by this. That is negative feedback, which is being given in terms of this all sort of amplifier. This is a voltage follower. Unity gain buffer to enable high impedance sources to drive low impedance loads. The non-inverting amplifier, the transmittance amplifier, the inverting amplifier, the summing amplifier, differential amplifiers, and things which are there with 3 amp and 2 amp. It has been given here. This all speaks about all sort of information what I have done. Yeah, these are things which you know to design circuits for different conditions. Thank you. And I would like to share about the links what I have referred for this talk actually, and it will be very useful to know. So there are specific conferences aligned to this topic. You can refer this conferences. They are flagship conferences. You can refer it. If you have articles with regard to these conferences, you can try to find and write papers and publish on these conferences. And it is not an easier case to publish these conferences actually. Sensor Expo or IEEE Sensor Conference, they are pretty much flagship conferences. And these are some magazines to refer. They are all free, and you can see, you can get the digest of every single day-to-day data about sensors. And I used to refer this IEEE Sensors Journal. I work in a very minimal area with respect to this sensors. I work with smart cities, IoT, and data management systems. So I do refer some sort of time when I want to cite some articles, when I want to clarify something, I do refer this IEEE Sensors Journal. And these are the specific websites I've collected information for this. I'd like to thank this, MIT courseware, and they have enormous amount of information. And these things can be used for the student, those who want to know about this, hacking gears through this, how sensors can be ethically hacked, or what are the information available, they can learn it over. Sensor model sources, you can construct model over here. Okay, this is all about my talk. Okay, I think okay, fine. Yeah, I'll provide all the PPTs. I'll upload to the committee member over there. Sure. So far we have talked about the IEEE industry for IEEE standard for the industry. Why I have been talking in the sense we are fond of using cell phones. Every cell phones have, it's been sensed to communicate data, to receive data that we want to know. Then I move to the types of sensors. Then I move back to the chart how this sensors works, how this input devices and how this output devices perform with respect to the quantified input we have been talking. Then we have seen some sort of, physics, theories and laws and circuit boards. They are not pretty much interesting, but I've referred to know this, to communicate as a building block to know about this all sort of industrial automation. Thank you. My talk ends, and I'll share my email. I don't think I don't. Ma'am, I have completed my talk, ma'am.
Yes, sir.
Yes, ma'am, I have completed.
Participants, do you have any clarification? Participants?
So anything related to, this research with respect to, topics on sensors, I can ready to help you out.
Yes, sir.
I know a few people out there.
Sir, now it's voice clear?
Ma'am?
1 minute, sir.
Yes, someone is asking to unmute.
Sir, now it's audible?
Yes, ma'am, audible, ma'am.
Sorry, sir. Issues.
Please let unmute. So anything related to research, you can ask me, even with your papers. I don't think, I know some,
Okay, sir.
yes, ma'am.
So what are the techniques we have used in position sensor, sir? No, which one is advanced one?
This global position sensors, ma'am. Actually, what we are using today is this GPS. They are just the advanced one. Actually, they do have this navigation system with respect to latitude and longitude, and they cover extensive radius with respect to commercial, research purpose. That is the advanced one.
You already told, no, the main type of analog as well as digital sensors. What are the application? In application field, we have to use this both sensors.
Yes, ma'am. For analog, something that is not be in really for commercial purpose. We are using in number of less in terms of analog actually. What someone is interrupting. Fine. Yes. For digital sensors, we had been using this. In terms of health industry, we have ultrasound. Or in terms of this, this e-commerce purpose, we have barcode sensors over there. We had been converted into that. We had been fond of using Google Pay. How they can sense actually. They all been into a QR code. We are into era of QR code. So every sensor can be able to capture QR codes with respect to payment or with respect to product purchase or e-commerce. We are into this QR code one. That is one classical application. We can say that these QR codes are very familiar, and we do have this RFID capture machines to scan these QR codes. Even you go through this, very big, Mega Mart or the shopping stores, you do have QR codes are pasted for every single products. So by storing all sort of items and using this RFID captured machines, you can easily run it through the prices and the product name. That is one single classical example I can say.
Very nice, sir. Sir, one participant is asking one question. What is the maximum sensitivity of temperature sensor available? In chat box, he posted, sir.
Maximum sensitivity of temperature sensor available actually.
How we can improve it?
Ma'am, I'll tell you one thing. I'm speaking in terms of research. It is not the point of improving or decreasing actually. With respect to the industry, when you take this, a very simple, health temperature. This thermometers, we can assess up to 103 actually. That is higher temperature of a body. We need an immediate attention. When you take a car or when you take, when you take an other motor industry, it is high actually. More than comes more than 500 to 1,000. Ranges between 500 to 1,000. So it is not the point of sensing them actually. It is the point of industry what we want to do actually. Purely speaking about this boiler industry, this temperature sensors are being used actually. They do have a higher quantification. Now in terms of kilo and in terms of megapower, they are being using actually, not in terms of Celsius or Fahrenheit. They do have a higher quantification in boiler industry. Tesla is using these sensors in their or some other kind. Yes, Tesla cars are different from, I mean, our regular petrol cars. They do are e-car. They call it as e-cars. As I'm very fond of knowing about cars, Tesla is one company they want to emerge into Indian market. They do have sensors for everything, like driving mode to parking mode. Now, this very few cars in India have this auto parking facility, this AI embedded auto parking facility. Not all the cars, even with your, I mean, Audi or BMW, they don't have this auto parking, sensing ability. Auto parking is a very tough one because this precision is to be assessed before you park a car in the parking slot. For auto parking, you need to have a parking slot to be assessed before. That means that if you make it as an entire mat, say for mat is a matrix, if you suppose you have a correlation coefficient of all the elements in the matrix are there, and you want to park in a car of 311, say for example, 311 is a parking lot, that mat needs to be assessed before, then only you can do that. India as a country, even though you have enormous amount of innovations with cars are there, and the parking slots have not been assessed, not been improved as high like as the cars, sensing industry has been improved actually. Please comment on the use of sensors and AI technology in future smart cities in India and potential threats. No, not really. We have enormous amount of security people are working on that. Even these cryptocurrencies are being, bought, and people are keep on using that. Even one of my students has been using a mining, in a mining system in her own home and using it as actual. Even this country has been banned this cryptocurrencies. He's earning like anything actually. So I don't think there will be a higher threat to this market. When you have a new innovation, there will be people to work on to protect that innovation. Fine. Yes, obvious there has always been a threat, but not like us, because one sensing or one AI technology is being released, people work like anything. There are enormous amount of people working for that to protect that technology. But very few people are trying to attack it or trying to breach it. Fine. And we do use this AESD as advanced encryption system and differential encryption system. They can't crack it. Now this iteration goes like anything. When you want to crack a machine, when you want to crack a packet through, if you can make it in 5 iterations, in the 5th iteration, the iteration will go to 10. When you are trying in the 9th iteration, it will go to 20. So whenever you are failing, the iteration number of iteration gains. Fine. That is what this RSA and elliptic cryptography. We have the strong crypto systems. I don't think, according to me, there is a less threat only. Please comment. Okay, fine. So how we can measure the bandwidth and energy consumption of any sensor in that we need an interpreter actually for measuring the bandwidth and energy consumption. We need an interpreter. There are different interpreters are available in the market. You can use that interpreter and you can interpret it, amount of bandwidth it consumes and the amount of energy consumption. While we are speaking about cell phones, it is being assessed in milliampere hour. When you buy a cell phone, you can check this 3000 milliampere hour, 4000 milliampere hour, 6000 milliampere hour. So when you have a higher milliampere hour battery stands for long time. We have applications to see the battery, consumption of the battery consumption. Even though your cell phone have a specific display says about the amount of energy is being consumed, you can have different applications actually. So it will say earlier before which application consumes amount of battery lot. So we can measure. Yes, you can use this interpreters. When temperature has to be quantified into, and the signal has to be quantified, right? The signal has to be converted and it needs to be interpreted. Then only you can assess it. Ma'am? I think I've answered for all these questions.
Yes, sir.
Thank you.
Madhyavan, sir, do you have any queries? Any clarification?
You can type it in the chat box. I can try to answer. Thank you. Thank you so much.
There is none, sir. Sir, shall I conclude the session, sir?
Yes, you can conclude. Thank you.
Thank you, sir. On behalf of our management, we thank our honorable resource person, Mr. K. Kottilingam, sir, Professor, SRM University, Chennai, who despite his busy schedule has found time to grace this session. And also our heartfelt thanks to him for his contribution to share their knowledge in the field of industrial automation using sensors, type of sensors used in industrial application, a wonderful explanation about positional sensor, analog and digital sensors. And also he has shared the useful links to publish the journals, hackers websites and sensors models we have used it.
Ma'am,
Thank
I
you,
would like
sir.
to, yes, ma'am, I would like to convey my sincere thanks to the head of the Department of Electronics and Communication and the management of P.S.R. Engineering College. One of my good friend who been introduced this, Mr. Sankar Ganesh. I would like to convey my sincere thanks to my friend.
Yeah, he
And
is here and please.
yes, ma'am. May I know your name, please, ma'am?
Renuga Devi, sir.
I would like to thank Amin for
It's
the
okay, sir.
smooth conduction of this process, Renuga Devi ma'am. And it has taken me 15 years to give a talk to PSR Engineering College because I had a pass out of PSR Engineering College in 2006. Thank you so much for inviting me. Thanks for your, inviting us as a guest. Thank you. Thank you so much. Thank you.
Thank you, sir.
Thank you, ma'am.
Sir, PPT will be showed participants.
Yes, ma'am. Yes.
That's it. But thank you for valuable and informative session, sir.
Thank you, ma'am. I'm leaving this. Thank you so much. Thank you.
Okay, sir. Okay, sir. One more information for participants. But PowerPoint will be showed to your mail ID later. Okay, I thank all the participants for their valuable contribution. Okay, we'll start the session, next session tomorrow morning 9:30. Okay. Thank you.